For centuries, humanity has gazed at the stars and wondered what secrets they hold. From Galileo's first telescope in the 17th century to the Hubble Space Telescope in the 20th century, each leap in technology has brought new discoveries, reshaping our understanding of the universe. Now, a new eye has opened on the cosmos. The James Webb Space Telescope, launched in December 2021, is the most powerful observatory ever built. Positioned nearly 1.5 million kilometers from Earth, it peers deeper into space and further back in time than any instrument before it. With its golden mirrors and advanced infrared vision, the James Webb Space Telescope is not just an upgrade. It is a revolution. It is revealing galaxies formed shortly after the Big Bang. It is studying the atmospheres of distant exoplanets. It is uncovering details of stars, nebulae, and black holes that were invisible until now. This is not just science. It is a new chapter in humanity's story of exploration. The James Webb Space Telescope is changing our view of the cosmos forever. The idea for the James Webb Space Telescope began in the 1990s. Even as the Hubble Space Telescope was transforming astronomy, scientists knew Hubble could not see everything. Its instruments worked mainly in visible and ultraviolet light. But the earliest galaxies, hidden behind cosmic dust and stretched by the expansion of space, could only be observed in infrared. Infrared light carries the fingerprints of heat, dust, and chemistry. It reveals newborn stars wrapped in clouds. It shows planetary atmospheres and the faint glow of galaxies from the dawn of time. To truly see the hidden universe, astronomers needed a new telescope. The vision was bold. A giant mirror more than 6 meters wide, instruments cooled to near absolute zero, a sunshield the size of a tennis court, and a position far beyond Earth's orbit, where the cold and darkness of space would give it a clear view. The telescope would be named after James E. Webb, the NASA administrator who guided the Apollo program. It would take decades of planning, engineering, and international cooperation between NASA, the European Space Agency, and the Canadian Space Agency. The project faced delays, redesigns, and rising costs. Many doubted it would succeed. Yet after more than 20 years of development, the telescope finally launched aboard an Ariane 5 rocket from French Guiana. On Christmas Day of 2021, humanity sent its greatest observatory into space. The story of the James Webb Space Telescope is one of vision, persistence, and the belief that the universe always has more to reveal. The James Webb Space Telescope is often called the most ambitious and complex observatory in history. Unlike Hubble, which had a single solid mirror, Webb required a segmented mirror made of 18 hexagonal pieces. Each piece is coated in gold to maximize reflection of infrared light. Together, they form a mirror more than 6.5 meters across, almost 3 times the size of Hubble's. But size was not the only challenge. The telescope had to stay cold, colder than -200 degrees Celsius, to detect faint heat signals from distant galaxies. To achieve this, engineers designed a 5-layer sunshield, as large as a tennis court, made of a special material that reflects sunlight and blocks heat. The telescope also needed to fold like origami. It was too large to fit inside any rocket in its full size. The mirror, the sunshield, and even the supporting structures had to be folded tightly, then unfold perfectly in space. Thousands of moving parts had to work in flawless sequence. Any failure could have doomed the mission. For this reason, Webb became known as the telescope of 100 risks. Its design brought together decades of innovation. Lightweight materials, cryogenic cooling systems, precision actuators, and cutting-edge detectors all had to function together. Webb was not just a telescope. It was a masterpiece of engineering, crafted to open a new window on the universe. On December 25, 2021, the Ariane 5 rocket lifted off from French Guiana, carrying Webb into the sky. For scientists and engineers, it was the culmination of decades of work, but the mission was only beginning. Webb was not placed in Earth's orbit like Hubble. Instead, it traveled nearly 1.5 million kilometers away, to a point in space known as Lagrange Point 2. Here, The gravitational forces of Earth and the Sun balance, creating a stable orbit where Webb can remain cold and undisturbed. The journey took about 1 month. Along the way, the telescope unfolded step by step. First, the solar panels extended to provide power. Then, the giant sunshield slowly deployed, its thin layers stretching into place. Finally, the golden mirror unfolded, piece by piece, until the full array was revealed. Each stage was monitored with intense precision. Engineers on Earth held their breath as hundreds of commands were executed. Any mistake could have left the telescope crippled. But one by one, each step succeeded. The deployment was flawless. By January 2022, the telescope had reached its orbit. Its mirrors were aligned with nanometer precision, and its instruments cooled to the required temperatures. Webb was ready to begin its mission. The successful deployment was celebrated as one of the greatest achievements in space exploration. Humanity had built a telescope that unfolded like a flower in space, ready to reveal the secrets of the cosmos. On July 12, 2022, the world saw the James Webb Space Telescope's first full-color images. They were breathtaking, not only in beauty, but in meaning. The first image revealed a deep field view, a tiny patch of sky containing thousands of galaxies. Some of the light captured had traveled for more than 13 billion years, showing galaxies as they appeared shortly after the Big Bang. For the first time, humanity could see the universe at such an early stage. Other first images included the Carina Nebula, a vast nursery where stars are born inside towering clouds of gas and dust. Webb's infrared eyes cut through the clouds, revealing newborn stars that Hubble could not see. It also showed Stephan's Quintet, a group of 5 galaxies locked in a cosmic dance of gravity, and the Southern Ring Nebula, the glowing remains of a dying star. These images were more than photographs. They were time machines. They allowed us to witness the birth and death of stars, the growth of galaxies, and the unfolding story of the cosmos. The release of Webb's first images captured the imagination of millions around the globe. Scientists wept with joy. Artists found inspiration. Children saw the universe in ways no generation before them could. Webb had fulfilled its promise. It was opening a new era of discovery. One of Webb's primary missions is to study the earliest galaxies, formed in the first few 100 million years after the Big Bang. These galaxies are faint and distant, their light stretched into infrared by the expansion of space. Hubble could see back about 13.4 billion years, but Webb extends even further. Within its first year, Webb discovered galaxies that may have formed just 200 million years after the Big Bang. These galaxies were surprisingly bright and massive, challenging theories of how quickly structure formed in the early universe. Webb's instruments allow scientists to measure the spectra of these galaxies, breaking down their light into chemical fingerprints. This reveals what elements they contain, how fast they are forming stars, and how they evolve over time. The telescope is showing that the early universe was more dynamic than expected. Galaxies formed earlier, black holes grew faster, and the first heavy elements appeared sooner than many models predicted. Each discovery forces scientists to refine their theories. Webb is not only answering questions, it is raising new ones. That is the essence of science. The telescope is not just confirming what we thought we knew. It is revealing that the cosmos is stranger, richer, and more complex than we imagined. Beyond distant galaxies, the James Webb Space Telescope is transforming one of the most exciting fields in modern astronomy: the study of exoplanets. These are planets orbiting stars beyond our sun. In the past 3 decades, astronomers have confirmed more than 5,000 of them, but Webb offers a new way to study them in detail. With its powerful infrared instruments, Webb can analyze the atmospheres of exoplanets as they pass in front of their stars. When starlight filters through a planet's atmosphere, it carries the fingerprints of molecules such as water vapor, methane, carbon dioxide, and oxygen. These molecules are potential signs of habitability, and perhaps even life. Within its first observations, Webb studied the gas giant WASP-96b and detected clear signs of water vapor in its atmosphere. For the first time, astronomers could see detailed chemical features in a distant world. The telescope is also targeting rocky planets in the habitable zones of red dwarf stars, such as the TRAPPIST-1 system, which has 7 Earth-sized planets. Some of these worlds may have conditions suitable for liquid water. By studying exoplanets, Webb is addressing one of humanity's oldest questions. Are we alone in the universe? While it may not provide a final answer, it is giving us the tools to search for biosignatures with unprecedented precision. Every new spectrum Webb captures is a step closer to finding another Earth, or at least understanding how diverse planets can be. The James Webb Space Telescope is also rewriting our knowledge of how stars and planets form. Its infrared vision allows it to peer inside thick clouds of dust where stars are born. In regions like the Orion Nebula and the Carina Nebula, Webb has revealed thousands of newborn stars and even protoplanetary disks, the swirling rings of gas and dust where planets form. These observations show the early stages of solar systems, similar to what our own sun and planets experienced billions of years ago. Webb also studies dying stars, whose explosions scatter heavy elements into space. These elements, such as carbon, oxygen, and iron, are essential for planets and life. By observing both stellar nurseries and stellar graves, Webb is showing the cosmic cycle of creation and destruction that shapes galaxies. Its images of nebulae are not only scientifically valuable, they are visually stunning. Pillars of gas stretch like mountains. Cavities carved by stellar winds glow with new light. These are not just astronomical objects. They are cosmic landscapes, revealing the grandeur of nature on scales beyond imagination. Through these discoveries, Webb reminds us that we are part of this cycle. The atoms in our bodies were forged in ancient stars. By studying the birth and death of stars, we are, in a sense, studying our own origins. The James Webb Space Telescope is still in its early years, yet it has already transformed our understanding of the universe. In the decades to come, its discoveries will only deepen. Webb will continue to probe the earliest galaxies, pushing ever closer to the Big Bang. It will study how black holes influence the growth of galaxies. It will map the atmospheres of dozens of exoplanets, searching for hints of life. It will reveal how stars and planets form, and how the raw materials of life are distributed across the cosmos. It is also preparing the way for future observatories. Missions like the Habitable Worlds Observatory, planned by NASA, will build upon Webb's foundation to directly image Earth-like exoplanets. Webb is not only answering questions, it is inspiring the next generation of technology, science, and exploration. More than that, Webb is reshaping how humanity sees itself. Each image is a reminder that we are part of a vast universe, connected by the same physical laws, made of the same cosmic dust, and sharing the same origins. The James Webb Space Telescope is not just a scientific instrument. It is a bridge, linking us to the earliest moments of time and to worlds that may harbor life. It is a monument to human curiosity, perseverance, and imagination. The story of astronomy is the story of humanity's expanding horizon. Every new telescope has pushed that horizon further, and every discovery has challenged us to rethink our place in the cosmos. With the James Webb Space Telescope, that horizon has expanded further than ever before. We can now see galaxies being born, stars emerging from dust, and planets orbiting distant suns. We can look back more than 13 billion years, nearly to the dawn of creation itself. These discoveries are not the end, but the beginning. Webb has shown us that the universe is richer, stranger, and more beautiful than we dared to dream. As you look at its images, remember this. Every point of light is a world, every galaxy is a story, and every discovery is a step closer to understanding who we are. The James Webb Space Telescope is changing our view of the cosmos, and in doing so, it is changing how we see ourselves.